Okay, so now we're going to look at the two-point high-low method in Chapter 6. And I saved this for last as far as your homework because it's probably the most comprehensive portion. I could assure you that you're going to have a problem from this chapter on the test, and you also have a problem from Chapter 7 as far as cost, volume, profit analysis on the test. So the first problem, 6.6, is a pretty simple problem. We get a list of months and labor costs for the year, I believe it is. I'm going to it. I didn't write it all down on here because it was just too much to write. So yeah, we were given January through December, and we have the number of customers and labor cost, and we're going to use the two-point high-low method. So we're going to have to remember that total cost equals fixed cost plus variable cost per unit times units, and we must always have dollars over units. What I have told students on ground to do is just write dollars over units in the top corner of any paper that they're working their homework on, or even on the test. And what I would do when we're in the classroom is I would write dollars over units in the top left-hand portion of the dry erase board, the chalkboard, so that everybody can remember it. Okay, so we went ahead and we found the high month, which was July, and we identified the dollars and the units, and then we took the low month, which was February, and again identified the dollars and units, and we found the difference between 20,500 and 10,450 is 10,500, and the difference between 5,000 and 2,400 is 2,600. So if we take our dollars over our units, we get a variable cost per unit of $3.87. One of the questions that students ask is how far do we extend out our decimals, and since we're looking at dollars and cents, we always go to the hundredth column, so we always have to the penny, I guess I should say. Okay, so that's our variable cost. Now we need to plug our variable costs and our high month into the formula of total cost equals fixed cost plus variable cost per unit times units. So our total cost for the high month is $20,500. Our variable cost per unit is $3.87, and our units are 5,000 in our high month. And we do the math, and we find out that fixed cost is $1,150. So we end up getting a cost formula of total cost equals $1,150 plus $3.87 times the number of units. And the last question asks us, what's our forecasted cost with 3,500 units? So we just plug the 3,900 into our formula, we multiply it by $3.87, and we add $1,150, and we get $16,243. Okay, so that was a simple one. Now we're going to get to the more comprehensive ones. I've actually color-coded what I've done. So here's what we do is the first thing we have to do is we have to identify if these costs are fixed, mixed, or variable. The red costs are fixed costs, and they don't change from month to month or from sales volume to sales volume. And if you look, I have 4 columns. I've got the 2 columns, or actually I have 6 columns, I apologize. I have the 2 columns that were given to me for the $2,000 worth of costs, and the costs at 2,000 units and the cost at 3,000 units. And then I have dollars per unit in the columns to the right of those costs. And I do that to see if it's a variable cost or a mixed cost. So when I multiply dollars per units, for the first one for wages, I take $40,000 and divide it by 2,000, I get $20. And then when I do it at 3,000, I get $60,000 divided by $30, which is $20. So that tells me it's a pure variable cost. So I move that over to the variable cost column. And then I go down and I do employee benefits, and when I do the math of dollars over units, I get $4.60 for at 2,000 room sales, but at 3,000 room sales I get $3.57. Those are in green because those are mixed costs. Okay, so since they're mixed costs, we need to separate those costs using the two-point high-low method. And then again, supplies is a variable cost, and I went ahead and did the math of 2,000 divided by 2,000. I get $1 or $1 per unit, and the same thing when I do the supplies for 3,000 units, because it's $3,000, it's $1 per unit. So we know that the variable cost is $1 per unit. So I move that over to the variable cost column. So right now what we have is we've got our fixed costs and our variable costs identified and put on the fixed cost and variable cost column, and you'll see why on the next slide. And our mixed costs we've identified, and those are in green, and we need to separate those using the 2-point high-low method. Okay, so here's all of the math. So first thing we need to do is we need to go ahead and just realize what we're doing. Our goal is to create that cost formula, or a comprehensive cost formula, for the entire income statement that we have. So we need to separate our mixed costs and employee benefits and in other expenses into their fixed and variable portion, and we do that by doing the 2-point high-low method. So let's start out with employee benefits. We take the high of $10,700 and the low of $9,200. We find a difference of $1,500, and then we take our units of 3,000 minus 2,000, and we get 1,000 units. When we do our dollars per unit, we get it $1.50 per unit. So we plug that $1.50 in under our variable cost column, which is right under the $20 that's in blue. If you see, I have it highlighted, or bolded rather. And next we need to go ahead and determine the fixed costs for employee benefits. So we use our total costs equals fixed costs plus variable cost per unit times units. And that gives us right here. And that gives us, when we plug things in, our total cost is $10,700, which is from our high month. Our fixed cost is what we're solving for, and we multiply 1.5 times 3,000 because we use 3,000 units at the high month. And our fixed cost is $6,200. So we move that over here to $6,200. So all we were doing right here is separating our employee benefits into its variable and fixed portion. Now we're going to go ahead and do the other costs. So we go ahead and take our high month of dollars of 5,000 and our units of 3,000, our low month of dollars of 4,000 and our units of 2,000. We find the difference, and it's $1,000 and 1,000 units. So our variable cost per unit is $1. We plug that in over here on our variable cost column, and then we solve for fixed costs. So our total cost for the high month are $5,000. Our units are $1, and our variable cost per unit is $1. Our units are 3,000. We do the math. Our fixed cost is $2,000. So we go ahead and we plug that in right here. I didn't bold that. I apologize. And it's $2,000. So now we have our costs for every single one of our expense lines. We find a total. Okay. Now on the next slide, we're going to use that total cost to create a formula. So problem 4 is to develop a single equation to estimate our costs. If we go ahead and take our total fixed cost of $44,200 and our variable cost of $23.50 per unit, we plug it into that total cost equals fixed cost plus variable cost per units times units formula, and this is what we get. And then for part 5, they ask us to project our total cost when we sell 3,500 rooms. So we just include the 3,500 into our formula. We substitute that for the units. We do the math, and we get $126,450. Okay, so now I have another comprehensive problem. The first thing I'm going to tell you is that we only use the middle column to identify the types of costs. So when we go to another slide, or the next slide, you're going to see that I actually remove that column because I no longer need it for my calculations, because we're only using the high month and low month. So the first thing we need to do is we need to separate each cost into variable, fixed, or mixed. The easiest ones are the fixed costs. Those are the ones that don't change regardless of volume levels. And if you look at rent and depreciation, rent's $10,000 or $1,000 across, so I put that under the $10,000 column. And depreciation is $200 regardless of sales volume, so I put that in the 200. And then again, I do my math of dollars over units. And for cost of goods sold, it's $1.50 at 3,000 units, it's $1.50 at 6,000 units, and it's $1.50 at 9,000 units. So I go ahead and plug that $1.50 over to variable costs. When I do payroll, as you can tell, the dollars per unit changes from $1.17 to 83 cents to 56. Those are in green. And that means we're going to have to do the 2-point high-low method to separate those costs. Supplies, again, is a pure variable cost. It's 20 cents per unit, regardless of the volume level. So we just plug that in under variable cost. And then finally, our other cost is 50 cents per unit when we do the dollar over units. We take 3,000 divided by 1,500, we get 50. When we take 6,000 and divide it by, or 3,000 divided by 6,000, we get 50. And finally, 4,500 divided by 9,000 is 50. So we just put the 50 cents over here. So we have our fixed costs for 2 of our lines, we've got variable costs for 3 lines, and we've got 2 lines that we have to do the 2-point high-low method on. So again, I've tried to simplify things so we can see where the numbers go. Everything highlighted over here are from our calculations down here. The first one we separate is payroll into its fixed and variable portion. So we do the 2-point high-low method. We take our high dollar amount and our high units. We subtract our low dollar amount and our low units from it, and we get the difference of $3,000 and 6,000 units. So our variable cost per unit is 50 cents. We plug that in over variable costs. Then we use our cost formula to find out our fixed costs. Our high month dollars is $6,500 equals fixed cost plus our variable cost per unit that we just calculated, 50 cents times 9,000 units, which is our high units. So we take our high units and our high dollar amount, we plug it into the formula with our variable cost per unit, and we get fixed costs of $2,000. So we plug that in. We go down and we do our utilities, take our high units, our low units, and we get a difference of 6,000. We take our high dollars and our low dollars and get a difference of $120. When we take our dollars over units, we find out that we have 2 cents per unit of utilities. So we plug that in up here. Finally, we plug in our high months cost in units and our variable cost per unit into the formula and solve for fixed costs. So we've got $480 for our high month in dollars. We get 9,000 units in our high month, and our variable cost we just calculated per unit is 2 cents. So 0.02 times 190, I believe, is 120. We subtract that, actually it's 180, isn't it? Let's do the math real quick. It's 180, I apologize. And I should have been able to do that in my head. And we subtract 180 from 480 and we get $300. So the final part was to develop an equation to estimate costs. We look at our totals up here. We total all of these columns and we get 3,500. We total all these columns and we get $2.72. It should be 272 cents. Oops. I don't know how I got 247 instead of 272, but just assume that for this right here is 272 units. So I've had students ask me, well, why do we do this? Why do we care what our variable cost per unit is? Well, if you had to manage these variable costs, where would you find the most bang for your buck? If you were to spend an hour trying to manage utilities and you can save a couple of dollars per unit or dollar amounts per unit, let's say, you're only getting 2 cents per room sales saving. Whereas, if you look up at cost of goods sold, it's $1.50 per unit. So there's a lot more room to make savings there. So we can look and see where our highest variable costs are and where our energy, most of our energy should be spent. And by the same token, if we look at payroll, which has a huge fixed cost, there's no way we're going to get that below $2,000 anyway. So we can manage it, but we should spend less time managing payroll as we should cost of goods sold in this example. All right, so we're going to go ahead and project total costs when monthly sales are 8,000 units or rooms. So we're going to take our total cost formula that we calculated, which is $3,500 plus $2.72 per unit times units. We're going to plug in the 8,000 for units, and our total cost when we have 8,000 rooms is $25,260.